Good morning, everyone, and I appreciate session chair, and also I really like to say thank you to for Aqua Congress for organizing this wonderful Congress, and we have so many people and from different background. My background is basically research, but I do work on applied research. Most of the things I do research, I make sure that they have immediate application. So today I will talk about rainwater harvesting, scarcity, what are the abundance, how we can make rainwater harvesting a good use in arid and semi-arid regions. I work in UC Davis. This is a little bit background about my department and my university. We have about 10 campuses in UC system, and one is University of California, Davis. It has a very strong veterinary department, has a very strong agriculture department, and most of the things are related with environment, public health, and animal health. So many people already talked about water scarcity, what are the problems with water resources. Of course, all the time we think about how we can bring more water for agriculture purpose. Many of you may know that still 80% of the global cropland is rain-fed land. We don't use irrigation. And 70% of the total food production in the world is coming from out of those lands. Of course, most of the poor people, many farmers are really poor, those who work in these areas, but they contribute substantially. If we want to uplift their economic situation, then certainly we must bring some additional water resources to provide some form of irrigation, such as supplemental irrigation. Some minimum amount of irrigation is needed to increase the crop yield. And my research is focused on basically how we can bring that supplemental irrigation through rainwater harvesting to improve the crop production. I would like to go back that when we talk about arid and semi-arid regions, and there is no definition, one single definition. If we talk about this side, this is basically Nile River Delta, many of you know. It is a lifeline for Egypt. But most of the agriculture is done along the Nile River, and rest of the country is like arid, there is no agriculture. If this side we talk about, it is a California, Sacramento Delta, you have a lot of agriculture, good quality land, but still entirely you depend on groundwater for irrigation. Without irrigation, we cannot produce anything. Third example where I was working, it's Iowa. Basically, it's completely rain-fed. You don't use any irrigation, and still it is one of the most productive land in the world. Most of the corn crop is coming from that Iowa, and at all, you don't use at all any irrigation. So there is no single, similarly, like there is no single solution for all the arid and semi-arid region lands. We have to focus on climate first. What kind of climates have an individual semi and arid regions? So there are two types of solutions we all the time talk. One is we can design large reservoirs. Those are kind of well-established technology, large reservoirs. And second thing is we can think of designing how we can use these small reservoirs, rainwater harvesting system, for generating some additional water resources which can be used for irrigation purpose. In a previous speaker already talked about a little bit Hoover Dam in Nevada. So, of course, we are not here to debate that big reservoirs are good or bad, but certainly there are issues. So, right side is Grand Hoover Dam, and I would say that if you get opportunity, please visit. It is really a wonderful dam, but in negative side, I think 25 years ago, Colorado River was able to reach to ocean. Past 25 years, it did not reach to ocean because of these reservoirs. Of course, they provide the water for drinking purposes, but there are substantial negative impact in the environment. This is a Colorado River near ocean, and you see it's like drainage ditch. It is not a river which used to be, and that is basically impact of reservoirs. These are on-farm rainwater harvesting system. They can be substantially useful to meet the local water demand. Basically, you can design in your farm and you can generate enough water to meet your irrigation water requirement. Right side is a little bit different. It's for roof rainwater harvesting, and I will focus mainly on agriculture purpose, basically rainwater harvesting for agriculture, small reservoirs. And if you can use this kind of technology, so basically you can have 7 billion hectare additional land to do the cropping system, and you can do more agriculture, you can increase the crop production. So the goal of this study was, what is the sustainable solution for this rain-fed cropping system? What are the sustainable water resources we can generate to meet the irrigation water requirement in a small region? And we have multiple objectives. That first we can perform some field scale studies where we can see the feasibility of the system, and then we can develop the mathematical model to see that how different climate regions will respond to this kind of rainwater harvesting system. So some part of this study was conducted at IIT Kharagpur in 2003 and 2002. I was also studying in IIT Kharagpur that time. I was involved in field study. And then I went to USA and I was more involved in modeling, formulating the algorithm and developing some simulation model to predict the rainwater harvesting potential and subsequent benefits. So this was the field study we already published, and that is about these reservoirs, how reservoirs, series of reservoirs were constructed within IIT campus. Some were lined, some were unlined, and we saw kind of 3 cropping seasons, and we wanted to see that how we can use this storage for irrigation purpose. Modeling part was a little bit complex, but again, modeling is nothing but the kind of putting things together, different types of equation to predict the evaporation, evapotranspiration, seepage, and then you can predict basically what the water requirement for crop. Then 2 years ago, kind of I took that work and I wanted to do further that how these reservoir system will respond in watershed scale. What will be the impact on downstream water? If you have multiple these reservoirs and big reservoirs, certainly you are going to have some impact on river water, groundwater, whatever the downstream water will be. I was talking about that these reservoir system will substantially, their benefit will be different in different parts of the world. So this is example in Texas and India. So if you see here in Texas, basically you get a small amount of water throughout the year, but the water is not enough to generate substantial runoff. And here in India, you have substantial amount of high rainfall during monsoon season, then you have substantial runoff, and your storage will be higher, and that can meet the irrigation requirement. So in Texas, it is not like rainwater harvesting is not going to be useful, but you need a different system. And for India, you need a different system. This is the field study which was done in IIT Kharagpur. So you see that at the end, when we needed irrigation water, we used this water for supplemental irrigation. And there are periods when you have enough storage, you don't need irrigation because there is already plenty of rainfall. That time you can use these reservoirs for aquaculture, for fish culture, and you can get additional nutrients resources. This is a simulation study which I was talking, that you see that this is a soil water, like green color, it's a soil water when you provide the irrigation using these reservoirs. And this red dot indicates that when you do not have these reservoirs, so basically you are increasing substantial amount of soil moisture. And here in this side, like you can see this figure, because we have these vertical bars indicates that you have a plenty of rainfall during monsoon season. So even you provide irrigation or you don't provide irrigation, you have these reservoirs or not, there is not going to be much change in soil water. Basically, you have enough rainwater. So you need basically supplementary irrigation in this cropping season. And this cropping season, when you have a plenty of water in reservoirs, you can use for aquaculture purpose. If you want to justify any system, we have to prove that it is economic, useful, or economically beneficial. So I did some simulation study, and I did find that these reservoir systems are more useful when you have a dry spell, when you have a dry condition, when you have a drought. But as rainfall is plenty, or we have a wet condition, maybe these reservoirs won't be so useful because we are already getting enough water from rainfall. In that condition, you can make more profit from these farms if you are using aquaculture or doing fish culture. In the past 4 or 5 years, I was heavily involved in stream water quality management, how we can improve the stream water quality. And I did a multiple kind of modeling study, and I did find that these reservoirs can be extremely useful to control the agriculture runoff. Basically, agriculture is also producing a substantial amount of pollution to ambient water. This is example in California, let's say left side. To meet the demand of meat, there are substantial, huge, large number of dairy farms or feedlots. You can see left side that as far as you can see, you will see just cow. And they produce substantial amount of manure. And now the question is where we can put this manure, because it is so much that it is beyond the need of fertilizer. So these are small, each dairy farm has to have storage, and they put all the manure into these kind of reservoirs. Then there are issues, groundwater contamination, and when they apply this liquid fertilizer or liquid manure into farm, whenever there is a rainfall, substantial amount of pathogens, nutrients goes into a stream. Another study which I did, actually I wanted to relate these reservoirs with stream water quality. So there are many pollution sources, but pathogens, elevated level of pathogens is the main reason in America for water contamination. In India, we do not have monitoring study, but look in America, about 53% streams are contaminated. Coastal water, 80% coastal water is contaminated. 98% Great Lakes are contaminated. 99% Great Lakes open water is contaminated. And the main reason for this contamination is basically agriculture, manure applications. Yesterday, there was one speaker, she was talking about that Yamuna River and we have problem with municipal waste. That could be only one reason. Like Morley mentioned just now, that water quality is really very complicated. Identifying the source of contamination, it's extremely difficult, and finding the solution even more difficult. So the problems are not so simple as sometimes we think. So these are the issues. Then you have contamination in stream, and you get aquatic life. Aquatic life also, they die because of low oxygen, high nutrient concentration in the water, algae growth. So coming back to my topic, what I would say that these kind of reservoirs, they can be useful for increasing the crop yield, maybe by 30 to 40%. These reservoirs can also be useful for controlling the pathogens or nutrient transport from agricultural land to stream water or ambient water. The benefit of these systems will differ depending on the climate conditions. So we cannot propose that everywhere we can build these reservoirs. We have to do some kind of simulation and climate study to find a suitable region. Thank you.